This paper is about the role of teacher implicit stereotypes and how they affect student outcome. And in particular, I will focus on the gender stereotypes of teacher in associating math with males. So let me start from a broad motivation and from a couple of facts that probably most of you know already. So the first one is that we know that women and girls in school tend to have like better performance in reading, but still like the gap is substantially large in math in most OECD countries, in most advanced countries. However, there is a second fact that is very important on the gender gap in math performance, and it has been shown, at least using cross-country correlation, that this gap is actually wider in those countries where there are stronger gender stereotypes. And for now, you can just think about countries where there is lower female labor force participation or like gender norms that associate more women with like housework compared to workforce. So the broad question that I'm after is whether exposure to stereotypes can actually have an impact on educational and occupational choices of individuals. However, as you can all clearly understand, it's very tough to understand the overall exposure of someone to stereotypes in their life. And so this paper will focus in particular on the role of teacher gender stereotypes and how they affect educational choices and achievement of students. I will do that in the context, in the Italian context, and I will analyze in particular the role of teacher gender stereotypes in affecting three set of outcomes. So we'll see the impact first on math performance and the performance in reading standardized test score. But then I will move on the choice of the field of study after the exposure of these teachers that somehow can speak about the longer, potentially longer term effect from this exposure. And finally, I will conclude talking about the importance of exposure to teacher stereotypes on self-confidence in different fields. So there are two main challenges that I face in order to address this specific research question. And the first one is the measurement of stereotypes. I use a tool that I guess most of you know, given the presentation of Eliana from yesterday or even before, that, but in this case it will be a gender science implicit association test. I will be more clear. I will go into detail in particular about this test and this test in my specific context. And from an identification perspective, I will exploit a form of as good as random assignment of students to teachers with different level of implicit bias within the same school and cohort, actually. Before continuing, let me clarify a couple of terms that I think are very important in order to address this question. So the first one is what we mean for stereotypes. So now we have like a very interesting framework from Bordalo and co-author in which they discuss the stereotypes as overgeneralized representation of differences between groups. And so in particular, in the context of math and literature, what you could think about, so this is the distribution in the Italian context, but it could be very similar if I would pick other countries. So in the red line, you see the standardized test score of girls, and the blue line is for boys. And what I plotted with this black line is the representativeness of types, which means for each decile of the distribution, how representative are girls with respect to boys. And what you can see is that clearly for math, the higher you move on the distribution, so the more like you go toward the top of the distribution, the less girls are represented compared to boys, but the opposite is true for reading. Just to give you a sense, like if we are talking about the bottom decile for math, we have almost like 1.5 girls every boy, and the same is true for reading, more or less. And so this is like what can somehow potentially generate stereotypes, because you get exposed to some part of the distribution. In particular, you can think about the top of distribution where like one of the two gender is overrepresented, and then you make inference on the overall population just about the representative of types in the specific part of the distribution.
So that would not be true in the U.S. The U.S. actually has a fairly large bias or gender bias in math scores, and they go for women.
No, actually, this is like from the PISA test score.
Yes, but for the NLS, even in the 97, there's a...
Yeah, so this is like a test score that we can compare across countries to understand how big is this gap. And what you can see is overall like that the gap is stronger in Italy compared to the US, but still is there also in the US for math.
But we have not been able to replicate that in a lot of different tests, the SAT.
So could I
So,
add no
yeah.
gender difference in SAT?
What?
Sorry, no gender difference in
I think
math?
the SAT has higher math scores for women. Now, what it's kind of hard to figure out is the very top end of the distribution, that sort of Summers argument, but the mean is
just one comment on that. So Larry Hedges did this meta-analysis of all these cognitive skill tests, and men and women, and on the quantitative ones, his finding was that boys were overrepresented in both tails of the distribution.
Mm-hmm.
Yes.
And there was a slight mean difference favoring boys. And by the way, that was a finding that led to the demise of Lawrence Summer as president of Harvard University, because he was discussing this very issue when he said, well, that's why we don't have enough women, because the far upper tail, the females are underrepresented.
No, exactly. That is what I was showing you before.
Yeah.
So it could be like with different tests, you have just some variation of that. But what we generally find that in the upper tail of the distribution, we have like more men, and these may somehow generate stereotypes when you infer it.
It's just that quite a few other studies have shown boys also overrepresented in the lower tail.
Exactly, but usually no, exactly. I definitely agree.
Yeah.
But the idea here is that you check the upper tail when you are interested in math, and therefore like you generate the stereotypes. Exactly. So this was only my point here. So the other crucial part is that people may have like stereotypes. So I may think that I may have these like implicit stereotypes or like a form of explicit stereotypes, but may not act upon the stereotype. They may not directly discriminate toward a specific group, but stereotypes may create a problem when they lead to discriminatory behavior. You can think about hiring, or you can think about like when I need to grade students in school, or it may be very problematic if they lead to a self-fulfilling prophecy. If girls perceive these stereotypes and they decide to underinvest in specific field. And so this is like this link between stereotypes and discrimination is not obvious and it needed to be shown. In my context, I will focus in particular on teachers' implicit stereotypes. And the idea here comes from the social psychology literature. We have like a bunch of studies that show that for elementary school teachers, math is considered more difficult for girls than equally achieving boys. And there are like important implications for what can happen within the classroom. So you can think about, I have a very tough math exercise to solve, I will challenge more the boys because I think that this will be the right thing for the whole classroom and both boys and girls. Or like when I needed to encourage one-to-one people to follow specific path of study later on, I may encourage more boys toward a specific field. And the crucial aspect that I wanted to point out here is that these kind of implicit stereotypes of teacher may act even without intention to harm the stigmatized group. You may do it because you think it's the right thing for everybody in the classroom, but still may have negative consequences of some of the groups.
Do you also consider the other on reading, like that boys are you also going to look at that?
I will also look at that. So this is like one potential way, but it could be exactly the same reason. It could work for boys and their underperformance in reading. So in a nutshell, what I will find is that teacher implicit stereotypes have a substantial negative effect on the gender gap in math. And this effect will be driven by girls with lower performance when they are assigned to teachers with stronger implicit stereotypes. However, there will be no effect neither on boys nor on girls on the implicit stereotype of the reading teachers in their reading performance. And I will discuss some potential reasons that can explain this result. And finally, I will move toward analyzing how teacher implicit stereotypes may have an effect on the choice of the field of study, finding that those exposed, the girls exposed to teachers with stronger implicit bias tend to go to less demanding high school after the exposure of this teacher during middle school. And I will conclude with some effects on the negative impact on self-confidence on girls. So there is actually a very broad literature on what is called implicit bias, that I will call implicit stereotypes, because as I said before, implicit bias comes into play only when we interact with others, and therefore we have a biased behavior. And what I will do to contribute to this literature is so yesterday you saw Eliana that was studying how stereotypes are somehow formed. Here I'm doing something different. I will be interested in how stereotypes affect others. But I will also collect for this paper information from 1,400 teachers with their gender science implicit association test and a lot of other factors to try to understand with which factors this is correlated. So this will be just a correlation. I will then move to explain how these how social conditioning, how exposure to stereotypes can affect the gender gap in math and in reading. And on that, I will contribute in part to the literature that exploited either self-reported measure or bias in grading, so difference between standardized test score and teacher-assigned grade. But no one has used the teacher implicit stereotypes in order to analyze how it can have an effect on students in a sample that is sufficiently large in order to have important implications. And here I will have 30,000 students that are matched with these 1,400 teachers. And finally, I will conclude with some evidence that on self-confidence, and I think this is particularly important because we know that women tend to have lower self-confidence in the scientific field compared to men, but what I will show here is somehow that this lower self-confidence can be activated by exposure to a gender stereotypical environment. So the setting is the Italian setting. I will focus on middle school that goes from grade 6 to grade 8. Students in my context are assigned to teacher in grade 6 and they stay with the same teachers throughout the period of middle school unless the teacher retires or is a temporary teacher and therefore change school. But usually in most of my sample I will have these 3 years of exposure. The class formation criteria is established by an Italian law and then is precisely clarified by the school council. But the general idea is that they stress an equal allocation of students according with gender and socio-economic background and the school performance. I will be able to see whether at my baseline this is actually the case. And to be honest, I focus on schools in the north of the country because we know that in the south of the country there is ability grouping that would have created some issue for my identification strategy. And after middle school, students are tracked into different high school. So there are 3 sets of high school. The first one is academic oriented, where the scientific and classical are the top tier schools, while the others are actually, to be honest, closer to the technical in terms of average ability of the students. And then there is the vocational track that is the bottom track in our system. So I went physically to schools to survey the teachers, and there were 102 middle schools located all around in the north of the country. So it's not just one city, but they are spread out in big cities in the north of the country.
Sorry, just to understand, because of that rule, you are assuming it's random? Or
Yeah, I have like a baseline.
I see, then you are testing.
Yeah. And I know, for instance, that in the south, this is not what they are usually doing. And so that's why like I excluded, I didn't even collect the data on teachers from the south for that reason. I interviewed 1,400 math and literature teachers using tablets. The take-up rate was pretty good. It was more than 80%, even if there was no incentive directly to teachers. And the reason is that we had like the strong support from the principal that was putting this like test within like one of the official meetings of the teachers in the school. And this is what was going on. So I was bringing physically tablets to the school. You see like each teacher has their own tablet, and they were completing the implicit association test together in the same room. So you know already how it works. There is a first trial part. In my context will be first we have like a scientific and humanistic subject.
So when is this done? When?
Yeah, I will come with the timeline. Yes.
Okay.
Yeah, I will be more precise of that. Scientific and humanistic subject, and then you have like a set of subject at the end, at the center of the screen, and they need to press the blue button either on the right or on the left. They have a second trial part with names that are female or male names, and the interesting part comes when they are asked to do the two tasks together. And what is crucial is that here there is always a clear right and wrong. So if like the word is in green, it belongs to one of the two green categories. So there is always the clear thing that they need to do. They just need to do it as fast as possible. And each of them does two types of this task, one in which they have scientific and female on the left, one in which they have scientific and male on the left. So if they are equally fast in doing the two tasks, they will get no bias, according with no stereotypes, according with my measure. If they are faster in doing task B, it means that for them, it's easier to associate the scientific field with males, and therefore like they put less effort in order to do that task. It comes out somehow more natural from a cognitive perspective. On top of the implicit association test, I also collected for a joint project with Eliana and a couple of other co-authors the race bias of these teachers, and I will talk about it only my last slides, so I will not use it here. But we have also a lot of information about the demographic characteristics about these teachers. We know a lot of things from their age, their entire career within the school system. We know the place of birth, we know the children, the age and the gender. So we have like a lot of very detailed information, demographic information. And we have also explicit beliefs of these teachers related to gender norms. I match this information.
Just a quick question. Maybe I'm not just trying to understand. Can you separate whether it's this implicit bias about girls in science versus implicit bias against boys in non-science, or is it's
No.
compounding both things?
It's compounding. So I cannot distinguish that because it's a two-target implicit association test, and it's always so one of the reasons why I will focus always separately on math teacher and literature teacher is because you can think that for math teacher it's easier to associate own gender with the subject that they teach. The same for literature teachers. So that's why like I will try to be within these people that are like in the same field and also in the same gender. I will also check that within field and gender the effect is still there. But it will be always a compound.
When you were motivating this, you said that an important aspect of this is that teachers believe that what they're doing is best for everyone. Is that something you also collect? And why do you think that that's an important piece of this? Because in some ways that requires a bit of self-awareness, that it's like goes beyond implicit. It's like an explicit belief.
Yeah.
That I really believe that, you know, me giving Dan more attention in math as opposed to you is actually actually good for everybody, you know, and so.
No, I say that it may be, it may come from implicit choices of this teacher, and they may not be fully aware that they are doing that. So, but here I will show you in my robustness what happens if I have explicit and implicit in the same regression somehow to understand what is driving the results. And they seem, just in a nutshell, they seem two different constructs, mental constructs. So you may have like one and not the other.
Do they get feedback on their score?
No, this is like the follow-up project that I will tell you in my last slide.
So they don't, right? Now.
So they don't.
And do people, again, I just don't know how it works with the implicit association test. Do people have a sense on how well they did based on doing it? So like, am I learning something about my implicit bias through the process of doing it, even if I don't get the feedback?
Yeah, so I'm pretty sure you learn something about yourself, because I mean, at least the first time I did it, I was getting upset that I was realizing I was making some mistakes. I was getting upset. So I'm sure that you realize something about yourself. So the interesting thing is how this something translates in how you behave toward others, and this will be my follow-up project.
You have variation when related to Basit's question, when you collected the data in the academic year?
Yes.
They could potentially see that already.
I have this variation, and I try to see whether this mattered, but it doesn't. But it's like it was pretty concentrated in like 4 months.
I see. Another way you can use the variation is to you have enough power to look at this self-fulfilling aspect, in the sense that, you know, suppose like I'm a new teacher and now, you know, I'm just starting, and, you know, and the more I interact with students, the more, you know, that confirms my biases. So can you exploit that?
Yeah, so unfortunately, I have very few teachers that are new teachers in the school, and they average, like, for instance, they have been teaching on average for 20 years in the school, so they have like a lot of experience in teaching. And so this is something that I've been trying, and I think for the gender part is something that is very tough, because you will get exposed to so many boys and girls that doesn't make so much sense if you have been teaching for 20 years. And indeed, I try to do that. I don't find variation. But for the race part, it could be more interesting, but when you have like few immigrants that you get exposed to. So I matched this data on the on the teachers with administrative data from 2 different sources. So the first one is coming from the Ministry of Education, that follows the career of students over time, in which I know, for instance, the choice of the field of study. And I have like the evaluation center that gave me the data on the teacher on the standardized test score in different point in time. I will be using mainly the grade 6 and grade 8. And finally, for a subsample of schools, only 1 cohort, I also collected some form of self-belief or self-confidence of girls in different fields, and I will show you at the end some results with a much smaller sample size, only for this subset of outcomes. So the identification strategy, I will show you evidence from 2 different identification strategies. So in the former one, I will exploit variation within the same class of boys and girls. So substantially, I will be interested in the gender gap within the class at the end of middle school, when you have substantially 2, a boy and girl that enter the same classroom with very similar background characteristics. And I will also include all the interaction between the gender of the student and characteristics of the teacher or characteristics of the student themselves. So this is the first exercise. It's interesting, but it's telling us just what happens to the gender gap. It's not telling us whether boys are doing better when they are assigned to more biased teacher or girls are lagging behind. So then I move to a second type of exercise in which I have a school by cohort fixed effect, and I'm interested in 2 girls that enter in the same cohort, in the same school, in the same cohort, but they are assigned to 2 teachers with different level of implicit bias. So there are a bunch of like potential threat to identification. So let me go through some of them. So the first one is that implicit bias is not randomly assigned to people. So for instance, here I'm showing you simply the gender and the subject they are teaching. So in the left-hand side, you see math teachers. In the right-hand side, you see literature teachers. And this is the distribution of their implicit association test scores. And you can see that math teacher, male math teacher tend to be more biased compared to female math teachers, but the opposite is true for literature. Also, partially because our implicit association test asks them to associate gender with field of study, and people tend to have like own gender and subject bias. So if I'm a math teacher that I'm female, it will be easier for me to do this task and associating a scientific field with my own gender. So this is important to keep in mind, and I will come back to it. I have a lot of other characteristics of these teachers, and I find very interesting that the background of the teachers in terms of where they are born. So all these teachers are living in the north of the country, but 40% among the math teachers are born in the south of the country. And they got exposed to stronger gender norms because there are stronger variation within the country since childhood. And what you find is that this implicit association test is capturing this exposure to different gender norms. You can use either a dummy or the female labor force participation in the province of birth, or like question related to the World Value Survey gender attitude in the place of birth.
Have you explored the heterogeneity with respect to the politics of the location? Because my recollection is that PISA scores look very good for Eastern Europe.
Yeah, so I can try to do it. So what I'm worried about is that it will be strongly correlated, because substantially if you take, so what you have, like if they are in the north, there will be a higher share for the league supporter compared to the south. So this will be for sure correlated, but I can definitely add that.
I don't want to break out and see the international, but I thought that the former communist countries, the gender gap was substantially attenuated.
Yeah, but okay, now that's very interesting. But yeah, in this context, I need to think a little bit more about it here. And the other thing that I want to point out here is that, so here you see the link between the World Value Survey question about the gender norms in the place of birth of this teacher in the column 3. In the column 4, I ask exactly the same question to the teacher themselves, and it is not correlated with their implicit bias. So there may be a lot of like social desirability bias in reporting explicit views when I'm in the classroom, and they are surveyed as teachers. So this is like something important to keep in mind.
So is there any sorting into public schools, or are they homogeneous? Like, I'm wondering like whether...
So 96% of schools in Italy are public school, and the private school tend to be the bad school, especially at this level.
Right, but like is like the characteristics of previous cohorts by gender in a school, is that correlated with the bias of a teacher?
Okay, so this is something I will show you. I will show you that. Okay. So the second aspect is exactly this form of quasi-random assignment, whether like some teachers that have more bias were systematically assigned to better girls in the past. And this is what I'm showing you here. That so I did a series of person chi-square tests on quasi-random assignment. Everything is fine. And also here I'm showing you some very simple correlation between the implicit bias of the teacher and, for instance, the share of whether like you have a highly educated mothers and these interacting with the female dummy immigrant, or like the standardized test score in grade 5. Notice that this is like the sample size is strongly reduced and it's not random.
I'm not quite sure. Tell us what those numbers are.
Yeah, so, sorry. So if you were assigned, there is a negative correlation of less than 1% between girls being a girl and being assigned to a teacher with more implicit bias. So, and all these, to tell you that these point estimates are very small, and substantially there is no systematic correlation between the implicit bias of the teacher and the characteristics of the student. If you think about it, it kind of makes sense, because this implicit bias is not something that you can clearly observe. You can only be worried that parents try to start selecting to observable, and only some of the observable are partially correlated with the implicit bias.
You check on for orthogonality respect to observable things of the teachers as well, in addition
of other teachers. So with some of the other observable, there is some statistically significant effect. Like gender, for instance, is something that I see some point in which they are statistically significant. It is always like something that I'm doing a lot of tests here, and they do not survive when I do the F-test. But yeah. And here to come back to the question about the timing. So I have like 6 different cohorts of students that now I'm using. So in the previous version of this paper, I was using only 3 cohorts of students because for 3 cohorts of students, I have like the standardized test score in 2 points in time. But this was done like a few months after the beginning of middle school, so this was not a good idea. So like at the end, I'm keeping like all cohort and just analyzing what happens at the end of middle school.
I'm sorry, going back to that last one, I'm just a little so female is a characteristic of a person.
Yes, exactly. It's a teacher level.
So the correlations are sort of attenuated by the variability within classrooms, right? People, gender varies within classrooms.
Exactly.
Yeah, so we would expect to see small correlations. Is that exactly the correlation you want? Are you just using?
So the point of this slide was to see that there was no systematic correlation between the implicit bias of the teacher
taking into account the aggregation effect. That is
exactly. So here there are school by cohort fixed effect. So essentially you have like a pool. Sorry. Yeah, sorry. So there are a pool of girls that enter the same middle school, and I want to see whether like the better girls are more likely to be assigned to the teacher with less bias. So this was the only correlation I wanted to show you here. So these are all different cohorts. So I will show you first the results, pulling all the cohorts together, and this is when the test took place. So the test took place between October 2016 and March 2017. Most of it was actually before January. There were only a few schools that were at the end. And I have some cohorts that were assigned to these teachers in the past. So they had like exposure in the past before taking the test, and one cohort that is after. And I will show you that the results are actually very similar for the 2 sets of cohorts. So this is like the fact that they are very similar is interesting because if I was using only this first part of the cohort, you would be worried about a form of a reverse causality. And on the other hand, taking the implicit association test may have an impact on like how they behave in the classroom. So using just the last cohort may have like a problem as well, because somehow you may affect how they treat their students in the classroom. But I will show you consistent results for both subsamples.
How did you solve the reverse causality issue?
So if I keep just this cohort here,
I see. Okay.
and I find actually the same point estimate. Actually, 1/3 of my sample will be from this cohort here. So this is like the overall effect. So in the first column, you see that girls in grade 8 are lagging behind of almost 0.2 standard deviation compared to their classmate boys in the same classroom. So here there are always class fix effect. To be honest, the effect is very similar when you don't include the class fix effect. In the second column, what I do is to include the interaction between the stereotype of the teachers and the gender of the student. And what you find is that girls assigned to a class with 1 standard deviation more bias of their teacher lag behind of additionally 0.03 standard deviation. So this variable will be not the raw implicit bias score, but is standardized to have mean 0 and standard deviation 1 to facilitate our interpretation. And so what I'm doing in the following columns is just to add student level controls like parental background, and then interacting that with the gender of the student. And in the last column, I'm including the characteristics of the teacher interacted with the gender of the students, because the level of the characteristics of the teacher is always already absorbed by the class fix effect, because everybody in the same classroom has the same teacher.
I'm worried how accurate your measure of the stereotype is.
There's a lot of noise.
Which means these are pretty badly attenuated, and they're already fairly large.
Yeah.
Exactly. Exactly.
Understood.
Yes. This is like this is for sure the implicit association test has a lot of noise inside.
Is there a retest test
Yes.
correlation that you could use to blow up the estimates?
So there is another paper that did exactly this test. That is the one of Mandy Palles, and this, she was suggesting that you should multiply by 2.8 the point estimate with like that. These are like a very, very strong effect. But this is like the other important thing is that this is 3 years of exposure. So this is the impact of like not 1 year. And actually, if I take like, so I have like 2 ways to go to the 1 year exposure, but I never find statistically significant effect on 1 year. It's usually less than 1 year because I have like few months after the standardized test score, but like just like few months of exposure doesn't give you this result. This is like the compound effect of like being assigned to the same teacher for a long time. Okay, let me show you, yes. Yeah, exactly. So this is exactly what I wanted to show you. So this is like the overall effect that I showed you before. If I separate by female and male teachers, that I think here is particularly important for the construction of our measure of implicit stereotypes, this association between gender and field, you find that, so most of the teachers are females. First, this is the crucial thing to notice. So most of the effect I was finding was coming from female teachers. But the effect is slightly bigger in terms of magnitude for male teachers. Okay. So this is like the result from the second identification strategy. So here what you can see is in the x-axis, you see the raw implicit association test score of the teachers. And here I have like a school by cohort fixed effect. As essentially, this is the kind of exercise in which I compare 2 girls that enter the same school in the same year, and I see that actually for boys there is nothing going on. Well, for girls, if you get assigned to a teacher with strong implicit bias, the effect is impressively linear. Actually, this was not necessarily true. This was an assumption of the previous slide, but this is not what.
If I take Amanda's results, you've explained 100% of the effect by moving from -1 to 1.
Exactly. So this is like this is impressive. So what it will be interesting to see is how long they last over time. A little bit connected with what was said in the previous presentation. So this is like the test they do just after this exposure for 3 years. And it would be interesting to see, like in the long run, how much this persists, and hopefully I will be able to do that.
But that matters through other channels, right? So if that changes your career choices,
exactly.
Even if, you know,
this was actually to prepare the ground exactly for that. Because it would be like one effect that you are getting worse, like at the end of middle school, plus you're going to worse schools, and you're learning less in those kind of schools. So there will be like a compound effect from both of them.
What are the min and max of the actual scale? Are -1 to 1?
So actually, how you calculate the score could be from -2 to +2, and so this is like just the sample that I have. So this is the same result with a regression form to show you that there is no the statistically different effect between boys and girls with the school by cohort fixed effect. Here I'm just showing you one heterogeneous effect, that is the one in the second column, where I restrict the sample to those students for which I have the standardized test score in grade 6. Because these are only 3 cohorts, but it's interesting to understand from which part of the distribution the effect is coming from. And you can see that nothing is going, so this effect, the -0.09, is for those girls that are in the bottom third of the ability distribution. The effect is very similar for those that are in the middle of the ability distribution. It gets positive for those girls that are in the top of the ability distribution, summing up the 2 coefficients, the -0.03 and the +13, but is not statistically significant for the top of the ability distribution. So what seems to be going on is the girls that were in the middle and bottom of the ability distribution are actually those that are suffering the most from exposure to teacher gender stereotypes. You could think about the others that were already able to stay at the top of the ability distribution, may have had like different role models or like different support from the family.
Is there variation in the gender composition of the classroom? If a girl is a female student is around a lot of boys, is the effect stronger?
So it's very similar. So they try, there is very little variation. It could be just a cohort variation, but I try to check for that, and it was very, very small. So it's not something that I don't even have like classes with 40% and 60%. So I will be very, very close to the 50%. But I should double check with the whole sample, because I did that in the previous version, to be honest, and I didn't double check.
So to follow up Leo's idea, did you look at interactions between peer effects and teacher effects? In other words, maybe it really matters that there's a successful female student in the classroom for the other.
So to be honest, I was keeping this idea for potentially another project, but so no, it's okay. But yeah, this is something that I really think is probably, that's why I was keeping all these part of peers like a little bit out from the story here, but this is a great idea. So, okay, and here the result on the literature. You see the point estimate is negative, much smaller, is not statistically significant. I tried to see heterogeneous effect. I was not able to find any interesting heterogeneous effect.
How big are those female differences, those main effect of female?
Yeah, so this means that girls are doing better in reading compared to boys in the same
Is that a standardized effect size?
Yes, it's very common.
It's
a
huge effect. Huge gender.
It was actually similar to the one in math. It was around 0.2 in math.
There's no symmetry in the effects.
There is no symmetry. So this is like, and some of the reasons, let me tell you what I think is going on. So we have like some papers that shows that improvement in math are easier to detect. So here we are seeing what happens in the improvement in math in these 3 years. And so if the standardized test score that I have in reading is less good than the one that I have in math, this can explain part of the effect. So maybe like the standardized test score is just capturing basic literacy, and they learn that in elementary school, the impact of their teachers and not any effect there. And so this could be one potential story. What I find like another interesting story that for now I cannot test. It would be nice to have like more data for that. So there is another very interesting paper from Mandy Pale that shows, and a bunch of co-authors that shows that exposure to bias manager, so to manager with stronger implicit association, race implicit association, has a negative impact on minority workers that are assigned to this manager. And one of the channels she was pushing was the contact theory, and the fact that these managers interact less with the minorities, and this somehow is a channel to explain the effect. So what may be going on is that for math, you need more interaction with your teacher in order to understand it fully compared to literature. So this is something that I cannot prove, unfortunately, because I don't have this interaction time.
So here the teacher is teaching both?
No, they are two separate teachers.
Two separate teachers. And you're not using this variation?
So I'm doing some robustness to see how it varies. So what happens is if you add both teachers, substantially there is always a negative impact of the math teacher in math and no effect of the literature teacher. And in reading, there is no effect of both.
So then this result is really the math teacher on the math.
Exactly.
Rather than.
Yes. And so the third explanation is more related to the stereotype threat theory and the idea that the girls may be, and actually there is one interesting paper in economics about that girls may be more vulnerable to the gender stereotypes, and they are more responsive to negative feedback in scientific field compared to boys in the humanistic field. So if girls react more to negative stereotypes or like negative feedback, this would be a way to explain the results. But these are potential alternatives.
There's an old result by Robert Rosenthal that basically boys are just not as good at decoding nonverbal behavior as girls are. So they're basically less susceptible to these implicit signals in general.
Yeah, exactly. So this I should cite it here.
I'm not really. I just thought it.
Yeah.
But I just thought it was an interesting.
Yeah, no, exactly. So it could be, it could go in that direction.
Yeah.
But here I'm like trying to make sense of a result, an empirical result.
And is math teachers way less biased? Like, you know, whatever.
So as I said at the beginning, I don't want to compare math and literature teacher for how the test is structured, because I'm asking in this test to associate math with like with gender. And therefore, like when I compare math and literature teachers, let's say the two different parts of the implicit association test may assume different value. So that's why I would not feel like comfortable with this.
No, but my question is just like, if you're trying to identify the impact of something that is not varying at all.
Oh no, there is the variation is very similar. So the standard deviation is very similar. It's just the level that is different. Yeah. So the second set of results is in the choice of the field of study. So I will show you two different ways of presenting this result. So the first one is with an ordered fixed effect order probit model, where I have like the three different categories, with the top track, the middle track, and the bottom track. Okay, and what you can find here is substantially that there is a negative effect on high school track choice, so they go towards tracks when they are assigned to a math teacher that has more stereotypes. And what's going on is that so I have additional columns with the literature teachers, and there is nothing substantial. They are not only the standardized test score is not affected, but also they are not affecting the choice of the field of study. In the first panel, I'm showing you the result on the actual track choice of these students. In the bottom panel, I'm showing you the teacher track recommendation. That is a formal letter that is sent to each family about the official recommendation of the group of the council of teachers of this student, and I find that this is also like negatively affected.
In the top panel, like is the effect still there once you control for the impact on the score?
Yeah.
Is that on top of that, or?
Yeah. So what is going on here in this is the first part that I showed you before. So in these two columns, what I do in the column number 5 is that I show you exactly the same result of column 4, restricting the sample for those students for which I have the standardized test score. Because what is going on for those students in the bottom of the ability distribution, they are less likely to do the standardized test score, and they go more to the vocational track. And so simply restricting the sample without any further controls, I have this point estimated that is not significant. And including also the control for the math standardized test score in the column 6, is not like affecting the point estimate, but still, like you see, is statistically insignificant. So that's why I'm kind of careful with this result.
Is there a way to evaluate this with respect to heterogeneity and family background?
Yeah. So I
just to play this out, that the stereotype interacts with the view that the kid's not going to go to college or going to go to high school, and it's either going to become a spouse or an unskilled worker. Yeah,
so the effect is stronger for those that have lower educated parents, but this is actually not statistically significant. Also because I have this missing category that is 1/3 of the sample on parents' education, and they tend to be like low educated. So if I put together the missing category with the low educated, it's significant, but that's why I'm not pushing this too much. Sorry, there was, okay. So the other way of showing, so if this odd ratio would be like 0.93, just to give you an idea, and this is, they are free ordered choices. So here I'm showing you the vocational track with a linear probability model that is the bottom of the ability distribution. And what you find is that substantially girls assigned to math teacher with stronger implicit stereotypes are almost 2 percentage points more likely to go to vocational track with an average of 17. So this is a pretty substantial effect for just one standard deviation, more bias of the math teacher. And what you see here is, again, the teacher recommendation toward a vocational track. This is the bottom of the ability distribution. If we go to the top of the ability distribution, the scientific track, there is no effect, even if the point estimate is negative. So those assigned to a teacher with more implicit bias are slightly less likely, but this is like by far not statistically significant. So I think that all the effect is going on in the bottom of the ability distribution that is actually coherent with the result I show you on the heterogeneous effect, that all the effect was coming from the middle and bottom of the ability distribution, and this goes exactly in the same direction.
Could you go back to one slide? I just want to make sure, I want to know how to interpret the bottom one, which of the effects I'm supposed to believe.
So this is the vocational track. The track.
I mean, column 2 versus 3 versus 4.
So I mean, if you don't see the stars, but you just check the standard errors, the point estimate gets smaller. But
so which one do you want me to take home?
No, I would prefer you to take home the last one.
Okay.
That is more complete. Yeah. So
Yes,
the idea is that.
Yes.
How often do they follow the recommendation?
So the probability depends on your socioeconomic background. So essentially, if you are like from a rich family and you are recommended a vocational track, you will not follow that. If you are in the bottom of the ability, you are more likely to follow it, but the correlation is like, if I remember correctly, it was around 0.6. They are still more likely to go to better school compared to what was recommended by the teachers. And if you see, the teachers recommend 35% of the girls to go to vocational track. That is the bottom of the ability distribution. This is a lot. 17% of them actually go to the vocational track.
So, just a question. If you hadn't found an effect on the teacher's recommendation, would that be necessarily inconsistent with your story? Because it's implicit.
No.
I mean, I'm saying, if it's an implicit bias, does that mean that it's going to
Exactly.
change my recommendation?
So that's why, like, I'm not. So that's why I was telling, like, you can check, like, the last column. I'm fine with that, because it's not inconsistent. Also, because this teacher tracker recommendation is like the group of teacher that is giving the recommendation. So somehow the math teacher has like a slightly less weight on them. But it's like I find it like interesting that the point estimate was going in the same direction. But I don't want you to take home that the necessarily like the second column is the right one. I'm fine with the last column. Okay, so the last set of results is on this measure of self-confidence. So first, see the sample size. So here we are talking about less than 800 students that I had, for which I had like this information on self-confidence. So this is like just one cohort and like few schools that were part of this additional data collection. This is like the outcome variable here is a dummy that assumes value 1 if girls say, if the student says that is good at math, versus like the alternative that is being mediocre or bad at math. What you see is that in the first column, girls tend to be less likely to say that they are good at math. So it's a 10% percentage point less likely to say that they are good at math. While in the second column, what I do is to add this interaction between the gender of the student and the stereotype level of the teacher. And you find that those girls assigned to teacher with a stronger implicit association are less likely to consider themselves good at math. And this is the case also when I add like a set of controls. The last two columns, and here there was a control for the standardized test score in grade 6 because I wanted to have like a sort of proxy of their actual ability in math. While in the last two columns, I'm including the mediating factors of the standardized test score at the end of middle school, because what I showed you before is that these girls are actually becoming less good at math.
So we shouldn't really believe the last column.
So this will be, it's not that you should not believe, it's like the residual factor there is residual importance of teacher implicit stereotypes when you control for the part of negative impact that goes through the grades. But I think it's still very interesting to see that the point estimate gets slightly smaller, but still is statistically significant at 10% level. And so I find it...
It looks like the coefficient is even bigger. The last one?
Yes.
105.9.
There was because I have like the teacher controls. So so I should add here the teacher controls so you could see. So part of the effect is captured by the teacher control interactive with the gender of the student. But substantially gets, so if you see compare these two columns, you see that it gets slightly smaller, but it seems to be like an additional effect that is going through like their self-confidence that is not fully captured by the standardized test score, at least.
But I'm not only concerned about the attenuation bias, but also about the size of your standard errors when you have a noisy measure. So, both for the high ability students and for this table, I suspect you're greatly there's a very high probability of a type 2 error.
Yeah. No,
Right, yeah, maybe it would be better to show a table that just gives us the big effect, the main effect of the thing, rather than trying to explain it and putting these things in, I don't know.
I think
but the only
you could at least do some back of the envelope calculations on how big the given Amanda's papers on how big the how inflated should the standard errors be due to the noise? I mean, this is sort of strong assumption.
No, yeah, right. So the only thing I wanted to make sure is that this was not like a mechanical effect of the fact that these girls are simply like worse at math. So this was like my point in trying to include that. But I agree that.
But you might want to just emphasize which ones your thick-headed people like me should actually walk home thinking is the best estimate, because as opposed to the more nuanced things that have the bigger standard errors and are more hard and are more difficult to interpret.
No, but the idea is that it depends on who you are and what you want. So if you wanted to know the overall impact of teacher stereotypes on the self-confidence, I will tell you, take home the column 4. If you wanted to understand what's the additional effect, you should take home like a column 6. So that's like
a little harder to believe. There's more assumptions and
exactly. But
so
that's why
you're estimating a direct effect in the mediation model, which is kind of a highly pretty strong assumptions, right? Maybe behind that kind of thing.
Okay.
Yeah, I don't know. It's a small point. It's I love this one.
Okay.
It's fantastic.
And so here is the fact on the math teacher in reading performance. And you can see that, interestingly, the point estimate is positive. It's not statistically significant. The issue here is that the first 2 subjects that they complete is like math and literature. So if I say that I'm very bad at math, I may be slightly more likely to say that I'm good at literature. So it may be like a framing effect.
So you don't see this crowd out in scores, do you? No, right?
No. So in the standardized test score, there was no effect of the literature teachers in the reading standardized test score, but
it's just like I switch. If I have a biased teacher in math, then I realize maybe I should allocate my effort to reading. You don't see that.
But I don't see that. If you have like a more biased teacher in math, you are not spending more time in reading.
I see.
Your point. Okay. And so I like this last set of a result, even if it's like coming from a smaller sample, not only because they can somehow provide a mechanism to explain the role, like how this all effect may play out, so it could be like through self-confidence, but also because I think that this is like the first paper to show that the lower self-confidence of women in scientific field impartially may be activated by exposure to a gender stereotypical environment. So it may be not fully innate that all women consider themselves bad at math, but exposure may matter. And in the paper, I have like a conceptual framework that now is moved to the appendix, in which I'm trying to put this self-confidence together with the performance to try to provide a test for the stereotype threat theory. But this was actually already done by Dee as well, so it's not like a big contribution of this paper. So to summarize, what I find is that teacher implicit stereotypes has a substantially negative effect on girls' performance in math. And this is mainly driven from girls that are in the middle and bottom of the initial ability distribution. There is actually no effect of the literature teachers in reading. And the interesting part is also that it induced female to self-select into vocational training or like lower level high school. They may have like a potential implication for the future accumulation of human capital. And finally, the last result was on this negative effect on self-confidence of girls. So now to the policy implications. So the implicit association test, as I said before, is a very noisy measure. It's not that bad in the test reliability, but it's still like not something that we should use at all for decision as hiring or firing, especially of teachers. I guess this will not be allowed as well. But the intuition is that we wanted to try to find a way to use this tool potentially to have an impact on policy. And so the paper that I was briefly mentioning throughout my talk is this paper that is with Eliana and another couple of co-authors that is about the stereotypes against immigrants of these teachers. And what we do that is, I think, particularly interesting is that we randomize the timing of the feedback about own implicit bias to teachers before they grade their student and right after. And what we find is that all teachers substantially give higher grades to immigrant students when they receive this feedback. But like we are working on this paper right now, so it's something that very soon we will be able to circulate, and therefore, like I think that here we'll have like something more to say on the potential policy implication of this kind of treatment, also like connecting this talk with like the last talk, the last slide of the previous talk on revealing implicit stereotypes to teacher.
So, just to make sure I understand, so you're saying that if you give people this feedback, everybody rates the immigrants higher, including the people who weren't biased? Or?
So most of the teachers were biased. Most of the teachers had stereotypes. That is different from being biased. So the interesting thing of that paper is that we were finding that math teachers were actually those that were biased in grading, while on average literature teachers were not biased in grading, even if they
really are so much better.
So this was about immigrants, but the idea.
Really are.
It could be that like they have different grading policy, and indeed we find that they are particularly generous with first-generation immigrants, while with second-generation immigrants the impact is actually negative but not significant. So it could go in that direction, but the interesting part is that when you give them the information, there is an update from
the only thing I was asking is, does giving the information just sort of make everybody put a premium, just everybody says, well, it looks like we better rate this group higher, or is it just correcting, is it just affecting the people who have the stronger negative view?
So the issue there is that I have like less than...
Are they just gaming the system, or are they actually correcting? Are they just gaming the system, or are they actually, is it ridding them of stereotypes?
So less than 5% have no bias among the... no stereotypes, less than 5%.
It could be they just...
but we can talk maybe more about that, because I think we have like it's very interesting, this dynamic of like whether it's just updating or like a correction of biases.
So just one quick piece of evidence. We have one result which makes us interpret it as not just gaming, which is we also ask them about explicit attitudes, and 20% say outright that if there is scarcity of jobs, Italians or non-immigrants should have a priority. Now, on that subset, revealing the stereotype makes no difference. So if you were aware that you are biased because you say it explicitly, our writing to you with the feedback does nothing. So if they wanted to kind of comply with something, they would also have reacted. And it seems to be on the people who were unaware, or at least didn't state it explicitly, that we find an effect. So that's the best we can do, given the absence of virtually non-biased teachers.
So I know that I ran out of time, so I don't want to keep you for lunch, but I'm very happy to take questions. So I don't know what I should do.
Anyone? Any other questions?
Yeah,
I
there was
just had
Submitted?
one, just on this, so do you have follow-up tests? Like, it sounds like you have one test, but if you had follow-up tests, you could see if there's a fade-out effect, or, you know, how much does it stay, or.
So the issue of that, this paper here is that we said to everybody that we were about to give them the feedback. We just randomized of one week or 2 weeks, the timing. So also the control group got treated 2 weeks after. And so that's why, like in this context, we cannot see whether you need to do this test every time before grading, or whether like giving the feedback once is enough to overall like solve the problem somehow. So that's why, like, I really think that more research should be done on this point. And also on the second component is more like on the decreasing the vulnerability of people to exposure to stereotypes. Also in this case of students. So this would be something else that like I'm trying to move my research toward. Yeah.
Thank you. Great.